Hi, I'm Paul Battaglia, and this is section 1.7, Transformations of Functions. I'm joined today by Brittany and Gabe. How are you?
Good. How are you?
Doing well.
Good. I think one of the things that we need to talk about when we talk about transformations are not only the rigid versus the non-rigid, but really how do we take the concept and take it out of the teacher's hands and put it into the student's hands? And I know, Brittany, you wanted to talk about some of the things you do.
Yeah, so first I would show them the different transformations through Desmos. And just let them kind of look at them and view them. And then I would actually tell them to get out their graphing calculators and do an activity with it. So that way they can actually see all of the transformations
So they're
themselves.
discovering them really by themselves. You have a chance to group the class together, whether or not some have seen or some have not seen them before. Mm-hmm. They get to kind of group up and see that stuff.
So what would you do in your activity?
So I would have the vertical and horizontal shifts and make sure that they can not only see what's happening, but then they would have to summarize what is happening.
Okay. So give like a verbal explanation of what each of those constants are doing to the parent function?
Exactly.
All right. Cool.
And I think that really lends itself there. We talk about those rigid transformations. Mm-hmm. Gabe, what do we do for the even more complex and trickier non-rigid transformations?
So these are always hard for students to grasp, the horizontal stretches and shrinks and the vertical stretches and shrinks. And something that I think is good to emphasize there is that when students are just learning it, they might be tempted to think, well, a vertical stretch is the same thing as a horizontal shrink,
right.
And a horizontal stretch is the same thing as a vertical shrink.
Right.
And it's nice to emphasize that that's not really the case. So maybe, I know they don't know trig functions at this point in time, but maybe show them a periodic function and sort of show what happens as you...
That frequency switch.
Yes, yeah, exactly.
Yeah, that works. I like that. I think, when we let the students discover these things, it's natural to see them maybe anticipate what might happen, which is good. But then at the same time, when you get to those compressions and shrinks, you'll have them assume that something is going to happen, especially horizontally, and then it doesn't happen. I think that's really important. I think one of the things that we can also do maybe is give them a visual idea. So now they come out of, Brittany, your activity where they've moved things on their own and they know. And then when we talk about how to connect this to the notation, maybe we give them a periodic graph and we label the graph f of x. Yeah. And then we say, do something to this graph to make it become f of x plus 2, or to make it 2 times f of x, that kind of stuff. I think when the students see these kinds of things, we as teachers can benefit because we catch on right away. We're getting that immediate feedback, that immediate assessment as to whether or not they're really understanding truly what they're looking at. What else do you guys do when it comes to addressing the errors that they might make? So Gabe, you told us a little bit about the compressions and the stretches and how you would adjust that. What do you guys do when you see students, let's say, accidentally moving something to the left when it should be to the right? Like, Brittany, how do you differentiate that for them?
I'd have them plug it in and solve it. So that's a way to say we always want it to be f of 0 in the end. And if you plug in, if you're moving to the left 2 when it's x minus 2, negative 2 minus 2 does not give you 0.
Okay.
So making sure that they see that.
So really illustrating the difference between the vertical shifts. When you add a constant, you're moving the function up. And when you add a constant for the horizontal shifts, you're actually moving the function to the left. So I think that's one of the big misconceptions. They think, oh, if we're subtracting, we're moving to the left. If we're adding, we're moving to the right.
And they need those kinds of tips too, because they need to see, like Gabe, just to what you said, if I'm going to be moving a function up or down, I want them to have something in their mind that allows them to come back to that. So I might say, we're pulling the shade up or down, that kind of stuff. And then, when we talk about reflections, I might talk about a calendar being flipped up and down versus the page of a book going left and right. So anything we can do, I think, to give them the opportunity to delineate between all of the all the things going on. Yeah. And then Gabe, you had mentioned earlier about using colors, right, to help them out a little bit.
So just sort of going along the lines of Brittany's activity, if you have a parent function, say y equals x squared, and you want to start drawing horizontal shifts, vertical shifts, even the non-rigid translations, you can go ahead and you can have them graph those in a bunch of different colors, and then as you're discussing them, have them write out verbally what each of those translations do to the graphs.
I think that's important too. That's a point we haven't talked about, which is, okay, so you see what's happening. I want you to tell me what's happening. Tell me, how this works. Tell me how this is going to happen. And then maybe even make predictions, give them equations and say, what do you predict will happen now after we've made all of these transformations together.
And then you could tie that back in using a graphing calculator or
Yep.
Desmos
And
just to
even
show what happens.
Desmos are the newer calculators. They're in color, so the students
Yeah.
can differentiate between the two. Yeah, completely agree. So I hope these tips have been helpful for you, and I hope you find much success in section 1.7.